Hi, everybody, and welcome back. So, last time we were talking about the features of a quadratic function if we were given a graph of it. But today we're going to talk about how to find all the key features of a quadratic function that we were talking about if we don't have a graph, if we just have the equation of the quadratic function. So, this is going to be more from an algebraic perspective than last time, as you can see right here. This is, I believe, still coming from section 8.2, though, if anybody, again, still uses the textbook for anything, which you should. It's a really good resource. But if you guys don't remember from last time, the main things that we talked about in quadratic functions were the zeros, the vertex, and the axis of symmetry. I know we also talked about domain and range. We're not going to talk about that as much today with algebra from an algebraic perspective. I mean, technically you would be able to figure out all of these things, including domain and range, without a picture. But maybe we'll get into that more a little bit later. So this is mostly the kind of stuff that we're gonna talk about today. All right. Because the big thing with this is that there is a formula to find the axis of symmetry given the equation of a quadratic function in standard form, which again looks like this. It's always going to be a vertical line. So going back to Hoy-Vux, it's going to be x equals some number. And if you have your quadratic function in standard form with everything all on the same side of the equal sign, the formula for it, I would definitely put this down in your notebooks, put a big star next to it. Negative b over 2a. It's the same kind of a, b, c system that we used when we were talking about like completing the square and quadratic formula and stuff like that. So this is your b coefficient. This is your a coefficient. Negative b over 2a. All right. That's going to get you your axis of symmetry. All right. And if you guys don't remember, we saw last time that the axis of symmetry was your x value of your vertex. All right, so if this gives you your x value of the vertex, you can then plug the x value back into the equation to figure out what corresponding y value goes with it, and then fully write the ordered pair that would represent your vertex. So, in the context of this problem, axis of symmetry is negative b over 2a. That's the formula. All right, so our b is negative 4. So negative 4 gets us positive 4 over 2 times a. There's an invisible 1 here. So a is negative 1. So this is 2 times negative 1. And then we would just simplify this using order of operations. 4 over negative 2 is negative 2. So the axis of symmetry, again, I will be looking for the actual equation of the line. So I do want to see x equals negative 2 instead of just negative 2. All right? That's the axis of symmetry. And then like I was saying, to figure out what the vertex is, this is the x value of your vertex. So you can take this and plug it into your original formula. So negative 2 squared minus 4 times negative 2 minus 7. All right, you could easily plug this all into your calculator as long as you're careful with your parentheses and your negative signs. But you can also do this by hand, again, using the order of operations. Negative 2 squared is 4, so this is negative 4. Negative 4 times negative 2 is 8, so plus 8, minus 7. Negative 4 plus 8 is 4, minus 7 is negative 3. So that's the y value of your vertex. And if this is your x value, that means the vertex of this parabola is negative 2. That's the negative 3. Negative 2, negative 3. There we go. All right? And that's this whole problem. So if we just go over that one more time, axis of symmetry is negative b over 2a. So b is negative 2. So negative 2 is positive 2 over 2 times a. A is 1, 2 times 1. So this is 2 over 2, which is 1. The axis of symmetry then is x equals 1. And again, 1 is then going to be the x value of your vertex. So we can just take it, plug it into this formula. 1 squared minus 2 times 1 plus 3. 1 squared is 1. Negative 2 times 1 is negative 2 plus 3. Negative 1, 1 minus 2 is negative 1 plus 3 is 2. So that's the y value of your vertex, which means the entire vertex is 1, 2. All right? Real quick, because I don't know if anybody's going to ask about domain and range. As I talked about last time, domain is going to be all real numbers pretty much every single time. And if you guys remember, the range is dealing with the y value of your vertex, all right? So it's got something to do with that 2 that we got right here in terms of this problem. And if you guys also remember from last time, we are able to figure out what direction the parabola is opening, like an up bowl shape or you can't even see it, this regular bowl shape or like a downward bowl shape, like a hill. We are able to figure that out from the sign of the a value. So since it's positive, it opens up. So it's going to look something like this, which means every other y value, if you have your shape like this vertex is at the bottom, right? So every other y value is going to be bigger than the 2 that we have right here. So you actually could figure out that the range for this would be y is greater than or equal to 2. But again, we're not really going to deal with that too much. I just wanted to talk about it just in case you guys were curious, because it does all fit together. This is exactly the same thing, though, as the last 2, so I think I am going to skip it for the time being, and we're going to throw zeros in with all of this as well. All right, so I hope we have a pretty good handle on the axis of symmetry and the vertex by now. Negative b over 2a. So this is negative 10, which is positive 10 over 2 times 1, which is 10 over 2, which is 5. So the axis of symmetry is x equals 5. It's always a vertical line. It's always x equals. We take that x value, which again is going to be the x value of the vertex, and we're going to plug it in here. All right, so 5 squared minus 10 times 5 plus 21. This is 25 minus 50. Ooh, this should be 21, sorry. So this gets you negative 25 plus 21 is negative 4. So the vertex is 5, negative 4. All right. The difference with this question and the last couple that we talked about is the fact that it's also asking us for zeros. How are we going to do that? I don't know if you guys also remember this, but in the last video, we talked about how zeros and quadratic functions are related, where if you are able to factor this quadratic trinomial, you're going to get you should get 2 answers most of the time. Maybe you'll get 1 answer. But those solutions that you get when you solve a quadratic equation by factoring, or even by any other method, whatever you get when you solve a quadratic equation, those are your zeros. All right. Like if we got, like if we're going to solve this in a minute, but let's say we get like 2 and 3, right? 2, 0 and 3, 0 would then be our zeros. All right. Because again, zeros is just a fancy word for x-intercepts in this case. So let's try to solve this by factoring. All right. Because factoring, I think, again, in my opinion, I would start out with factoring. Technically, again, you could use whatever method that you want. What are the other ones? Square roots, completing the square, quadratic formula. Quadratic formula will work every single time, but it is pretty complicated. So I'm going to factor this. You're going to see me factor on a lot of the answer keys with this, but if you want to use quadratic formula, go for it. Anyway, when we think about factoring, again, we're thinking about factors of 21 that add up to negative 10. So what are factors of 21? They're 1 and 21. They're 3 and 7. You can make them negative. All right. Which of those pairs would add up to negative 10? Well, 3 and 7 would, because 3 plus 7 is 10, as long as you made them both negative. Negative 3 plus, minus 7 is negative 10. So when you factor this, this is x minus 3 and x minus 7. All right. That's just the factoring part. And again, this only works if you have it set equal to 0. Because again, if you think about it, right, zeros just mean x-intercepts. And what we know about x-intercepts is the fact that the y value is always 0. And if you guys don't remember from all the way back in chapter 3, f of x is just a fancy way to say y. So once we find these zeros, we are actually replacing this f of x with a 0, and then it makes sense, like what we're doing actually makes sense, all right, when we factor this and then when we set it equal to 0, all right? And then we're doing this the same way that we solved by factoring in the last unit. We're going to split it up. X minus 3 equals 0, x minus 7 equals 0, and then solve them both. So x is 3, and x is 7. But we're talking about zeros. Like now we're talking about things involving graphs. So we're talking about zeros and y-intercepts. So I will also be looking for you recognizing that these are not just solutions, but ordered pairs. So I will be looking for something like 3, 0, and 7, 0 as the actual answers to this problem. All right? And that's it for this one. All right, I think let's do this one. Okay. We're doing it all over again. All right, negative b over 2a for the axis of symmetry, negative 24 over 2 times 6, which is negative 24 over 12, which is negative 2. So the axis of symmetry is x equals negative 2. We're going to plug that in here for x to find the y value of our vertex. 6 times negative 2 squared plus 24 times negative 2. So order of operations, exponents first. Negative 2 squared is 4, times 6 is 24, minus 48, plus 18. 24 minus 48 is negative 24, plus 18 is negative 6, I think. So the vertex is negative 2, negative 6. All right. Now, again, we can replace this with a 0 and try to factor it. All right, I'm actually going to rewrite it down here this time, because one of the first things, please don't forget about this, to think about when you're factoring is to try to take out a GCF. The last one didn't have one because the leading coefficient was 1. Here, it's not 1, so we're going to think, are 6, 24, and 18 all divisible by the same thing? Yeah, they are. They're all divisible by 6. So we're going to divide that out first. So we're left with in terms of our coefficients, we're left with 1, 4, and 3. So this is 6 times x squared plus 4x plus 3. There's no variable component to the GCF because they do not all have a variable. All right? And then we're going to try to factor this. Lucky for us, there aren't very many factors of 3. They're only 3 and 1. And 3 plus 1 is 4 when they're both positive. So this factors down to x plus 3 and x plus 1 equals 0 with the 6 GCF on the outside. But again, setting 6 equal to 0 as part of our solving does not make any sense. All right, 6 is never equal to 0. So the only pieces that we're setting equal to 0 are these two expressions with the variable. All right, and then we solve. Oh, so this is negative 3, sorry. There we go. So those are our two solutions, but again, we're talking about zeros, x-intercepts, ordered pairs. So the actual final answer would be negative 3, 0, and negative 1, 0. And there you go. All right. Again, I think I'm going to hold off on this. Oh, that's actually it. All right. So I think we'll call it there. I'll do this one later. You guys will have the answer to this one. And a quicker video for today. All right. Hope it wasn't too bad. Again, feel free to contact me if you have any questions. And I hope you guys are continuing to stay safe out there. Talk to you soon.